So Assalamualaikum Dr. Hasnul. My name is Muhammad Suli Fahmi, and here I am with Nurul Ashikin, who will be presenting on a mini project titled Closed Steam Iron, and we are from Group 11. Now I'll pass the presentation to Nurul Ashikin for the product background.
Thank you, Sulhi. Now I'm presenting about the project background. During the heating process, a cloth iron, which is also known as a flat iron, smoothing iron, or just iron, is used to press cloth in order to remove wrinkles and unsightly creases. It was given this name in honor of the metal, which is iron, from which it was originally fashioned, and its application is generally referred to as ironing, which is the final step in the process of washing garments. By ironing, you can loosen the bond that hold together the lengthy chain of molecules that makes up polymers fiber materials. When exposed to heat and weight, fiber are stretched and the fabric holds its new shape after it has been allowed to cool completely. In some materials, such as cotton, water is required to release the intermolecular connection between the molecules. Next, the bill of material and the existing product. This table shows the bill of material of the cloth iron, which is from the type of the steam iron that have a 10 component and only spray button have a quantity of 2. The rest of it only have 1 quantity. The material, most of the material is made from the plastic, and most of the component require the manufacturing process of injection molding, since it made from the plastic. So the base plate component is made from the material of the aluminum and steel, and the manufacturing process is the sand casting. For the handle and the spray button, both of it is from the manufacturing process of injection molding, but the material is different, as handle is made from the PVC and the spray button is made from the ABS. As for the screw, the material is from a steel and the manufacturing process is machining. The control knob and water-filled cover is the same material and same manufacturing process, which is the material of ABS and manufacturing process of the injection molding. The water selection, the material selection is from material of the PVC and manufacturing process of the injection molding. As for the component of wire, the material is from the PVC and rubber, which is manufacturing process is the wire drawing and annealing. As for the jet steam button and heel rest, both of it is from the material of ABS, and the manufacturing process of it is the injection molding for both of it. This is the figure of the existing product, which is the cloth iron of the steam iron. Next is the DFA table of the existing design product. This table is required to count the total operation time and the total assembly cost for easier to calculate the design efficiency and also the assembly cost. The total quantity of the part is 11 and the TMPC of it is 6. The total manual handling time in second is 18.12 seconds. The manual insertion time is 47 seconds, and the total operation time is 72.12 seconds. The total assembly cost of the existing product is 54.09 cents. The design efficiency from the table is a formula of DE is equal to TMPC times V3 divided by the total assembly time. So that we get the result is 20 DE for the existing product is 24.96%, and the assembly cost of the existing product is if the salary operator is 27 ringgit per hour, using the formula of assembly cost is equal to assembly time times with the labor rate. So the result that we get is RM.0.405%, which is 40 cents. So that's all from me. Now I will pass to Sulhi to explain about the details of the improvement. Thank you.
Okay, thank you, Nurul Ashikin. Now I will explain on the details of improvement. Okay, as you can see here, the button has been combined into one button to save the manufacturing process. And then for the heel rest, the hole has been removed as the screw has been removed. Now there's only a blank space there. And now the discussion on the improvement. There are a few reasons why we improve design. This is due to the employing a fewer parts, reducing labor, and then reducing unique parts, and overall we can actually reduce the cost of this of the assembly. And then by lowering the part, we can actually raise the reliability of the product, therefore decreasing the likelihood for the product to fail. And then later on, it has the potential to improve the product quality and long-term viability. And now we have the drawing of improvement part and final product. Here we have the technical drawing of the part that has been modified. And now we have the DFA table for the improved part. As you can see here, the total quantity of the product has been decreased into 9 parts. And the minimum part count, it has 6, still 6. But the most difference that we can see is at the design efficiency. It is at 33.6%, and the assembly cost as well, which is now we only at 30 cents per product. The assembly cost was calculated by the total assembly time times the labor rate, which is the 27 ringgit per hour. And then now we have the comparison. Okay, comparison between the existing product and the improved product. First, we have the total parts. The existing product requires 11 parts, and the improved design only required 9 parts. The total assembly time in seconds for the existing product is 72.12 seconds, and then for the improved design we only have 53.55 seconds, which is the difference is 18.57 seconds. And then the total assembly cost for the existing design is 40 cents per product, and then for the improved design it only costs around 30 cents per product. And then we have the design efficiency. For the existing product, it is at 24.96%, and then for the improved product, we have at 33.6%. The difference of the design efficiency between the existing product and the improved product is 8.64%. And now the conclusion and the recommendation. The conclusion is DFMA, which is the design for manufacturing assembly actually. Method is very useful to analyze the current cloth iron design. It is proven to be improving the design efficiency and operating cost for the product. And then it is also improved significantly. It is because the product will require less effort, time, and money due to reduced part number and part count. And then furthermore, the spray product, the spray button part is combined to be one, and the heel rest does not require a fastener, which is a screw to attach to another part. And the finding of this study indicates that the DFMA method has been proven to be helpful in reducing the production cost as well as number of parts. Thank you.